As well as having to answer pseudocode questions in paper 2, which is the programming paper, you'll also have to probably do some sort of tracing. You'll either have to trace flowcharts or you'll have to trace pseudocode. Okay, we're going to have a look here at tracing flowcharts. These two examples that we're going to look at are from previous exams. This one is from the sample paper that's available to everyone, and the other one is from a 2016 paper. Okay, all you have to do is you need some basic understanding of how flowcharts work, but other than that, it's pretty much common sense and very, very basic mathematics. So if you can add up basic numbers, okay, and then have a little bit of information on how these work, then you can get full marks. And there are a lot of marks available here. There's 6 marks here, okay. How they are marked usually is per column. So this will be 1 mark, that will be 1 mark, that one, that one, that one, and that one. So you have to make sure that you don't have any errors going across, okay, because it might get all of the marks knocked off for all of the columns. So this is a more simple example, and then I'll have a look at a more difficult example. So this one says, the flowchart inputs the size of a number of car engines with a value of -1, stopping the input. Okay, the information is out. This information is output, average engine size and number of engines with size greater than 1.5. Okay, all you have to understand is that this rounded rectangle here is the start and the end of a flowchart. These ones are process boxes, okay, that's just something that happens. And these ones here are inputs and outputs. So if something is input into the system or if something is output from the system, it will go in one of these. And finally, these ones here are questions. Every question has a yes and a no coming out of it. Alright, so let's have a look. This one starts, and the first thing that we have to do is we have to declare our variables. Okay, it tells you, basically the best thing to do with this is not try and figure it out in your head what's going on. Okay, that will come later. The first thing you need to do is just follow it step by step. Right, most of the reasons people lose marks on these is because they're overthinking it. It's much more simple than you think. Okay, so to start, it says engine is 0, count is 0, and number is 0. Okay, this little thing, the arrow pointing left in pseudocode, is the equivalent of equals in programming. So engine is 0. So all we have to do in engine is write a 0. Count is 0. Okay, and number is 0. Right, now it says input size. If it says input something, then you need to look around the question somewhere and it will give you the input data. Okay, we can't do this without this information here. Okay, so the first size we need to input is here, it's 1.8. So input size, whatever it says, input anything, you just look around the question. Well, you should have read it anyway before you started it, but if you can't find it, it's always somewhere above the table, the data that we're going to use. So the size that we're going to use is 1.8. Okay, so now we just follow it. Is the size -1? Right? No, it's 1.8. So we're not going to go across there. We're going to go down here. Is the size greater than 1.5? Yes, it's 1.8, which is greater than 1.5. So count becomes count plus 1. When it says something becomes something plus 1, you just add 1 to it. So whatever count was before, okay, we add 1 to it here. Also, sometimes on these questions, in the mark scheme, I've seen that these declaration of these things here, okay, are done on one line, and then we start on the next line here with our input. Okay. However, if it's marked vertically, it doesn't really matter. So we've got size 1.8. Here we are. Is size greater than 1.5? Yes, it is. Count is count plus 1. So count is 1. Then we follow around here. Number is number plus 1. Engine is engine plus size. Okay. So engine currently is 0. Yeah. And now we want to make it engine plus size. So 0 plus 1.8 is 1.8. Now we're going to go right back to the top here. We're not going here because this would mean that we reset all the variables to 0. We're going just underneath to input the next size, 2. Okay, oops, not that one, there. 2.0. Okay, what I'm going to do actually, I'm just going to move these down, these ones here, okay, because then the 1.8 obviously corresponds to this line, okay, so 1.8, 2.0, okay, so 1.8, 2.0. 2.0 is the size minus 1? No, it's not. Okay, we can skip this because you can see along this data here, the only one that's minus 1 is the one at the end. So until we get to the end, we just keep going down this way. Is the size greater than 1.5? Yes, it is. Count is count plus 1. So count is now 2. Number is number plus 1. Okay. And engine is engine plus size. So 1.8 plus 2 is 3.8. There we go. Okay. Next one. Back up to the top, input the size. If you want, you could go down the size and you could just put all of these in. Okay. Because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've got lots of free space there, so you've got room for it. So I'm just going to go through. Actually, no, I'll just do it like this. So input the size, 1.0. Is the size minus 1? No. Is the size greater than 1.5? Okay, this time it isn't greater than 1.5. Okay, so what we're going to do is we're going to skip out this. Every time it's over 1.5, we add 1 to count. However, this time it's not over 1.5, so we're not going to add 1 to count. What we're going to do is we're going to leave count as it is. Now, if you are leaving a number as it is, I'd say to leave it blank. You could theoretically just keep putting 2 in there. You could put another 2 because it's not increased. However, I'm going to leave it blank. Number, however, does go up. You can see that every time, whatever happens here with this bit, number always goes up and engine always becomes engine plus size. Okay, so number is going up this time. Right, 3. Engine becomes 4.8 because we've got a 1 added to it, because remember, engine is engine plus size. Okay, so now the next one, 1.3. Right, is it greater than 1? Is it minus 1? No, it's not. Is it greater than 1.5? No, it's not. So number, we add 1 to it, and we always add it onto there, so we've got 6.1. Okay, right, next, input 2.5, 2.5, sorry about this mess. Where are we? 2.5 is obviously it's not minus 1. Is it greater than 1.5? Yes. So we're going to add 1 to count this time. Okay. So look what happened here. The 2 times that it wasn't greater than 1.5, we didn't add 1 to count. However, now it is greater than 1.5, so we're adding 1 to it. It was 2 before, now it's 3. We always add 1 to this one here, and therefore the engine size is now 7. I missed one out here. I've missed out a 1.0 there. Okay. There we are, 1.0. Okay. So we missed that one out. Is the size greater than 1.5? No, it's not. Number is number plus 1, 5, and that is 7.1. And now we're on to our 2.5 one. 2.5. Number is 6, and that will be 3, and 2.5, that makes 9.6. Okay, nearly done. 2.0. Look at what's happening here. Nothing, because at no point have we gone to this bit where it says about the average and it says about the count, output in the count, sorry. So nothing has been output yet because we haven't gone here. Nothing's happened to the average because we haven't gone here. 2, is it greater than 1.5? Yep, so we're going to add 1 on. Okay, so there, we add 1 anyway, and we're also going to add 1 onto here, and we're going to add that, so it becomes 11.6. Okay, and then we've got 1.3. Eventually you might figure out a system So you don't have to keep going through it. We figured out that every time it's over 1.5, we add a count. Every time it's not over 1.5, we don't add a count. So number is 8. We're not going to add a count to that one. However, we are going to add it onto this, and that is 12.9. 1.3, 1.8. Right. That is over 1.5. And so it gets added onto there again. That's 14.7. Okay. Finally, in terms of the ones that aren't -1, which is going to stop it, we got 1.3. It's not over 1.5, and therefore we're not going to add anything to this. We are going to add it to this. Right, now let's see what happens with our next one, which is -1. So now we come to this thing here, and our option has changed. It is now -1. So average becomes engine divided by number. Okay? So how do we do that then? So our average becomes engine divided by number. So 16 divided by 10, we're just going to move that decimal point there, and it's going to become 1.6. Okay, and then we're here. This is an output. Okay, like this, it's a parallelogram, and therefore it means output. It even says it on top. Output the average and the count. So whatever it says here goes into the output column. Even if you've written it here, you need to output the average and count. Otherwise, you won't get this mark for the column. So simply, it wants me in the output column to write average, count. So my average is 1.6 and my count is 5. So 1.6 and 5. Just put a comma between them, and then we stop. Okay, and that's the end of that. So that one is relatively simple. The next one is a little bit more complicated. Right. Okay, so this one is a little bit more difficult, but it's the same system. Basically, if you follow this exactly and you can do some basic mathematics, then it's pretty difficult to get it wrong. As I said before, the reason people do get these wrong is because they overcomplicate things in their heads. They don't follow this, they try and make assumptions, and it just falls apart. But if you just simplify it and you follow every box exactly as it's written, and you write it exactly as it comes out in here, you will get that 5 marks. As I said, it's marked by columns. That's why this is 5 marks. The other one was 6 because this only has 5 columns. So it says the flowchart below inputs the price of an item under $10. The change from a $10 note is output. Any amount less than 5 cents is rounded up to 5 cents. Okay? The predefined function int rounds a number down to the nearest whole number. For example, z becomes or equals int 5.7, gives the value z equals 5. It's important to remember that int rounds down. So even if you got 5.9, you don't get 6, you get 5. Okay? So let's make a start. You can see we've only got one piece of data here, right? We don't have a big list. We've just got one. So it says here, input price. This is our price, and therefore we put this in 6.29 there. Change becomes 10 minus price. 10 minus 6.29 is 3.71. Okay? The reason I've put this on a different one is because, as I said, sometimes in the mark scheme, they have the first calculation after the declaration of the variable on the next one. Actually, just to not complicate that, I'll put it on the same one. What did I say it was? 3.71. It doesn't matter because, as I said, they are marked vertically. So 3.71, is the change is the change greater than or equal to 1? Yes, it is. 3.71 is greater than or equal to 1. Therefore, dollars becomes int change. So dollars becomes int change. It doesn't become 4 because, as it told us up here, we round it down. So dollars becomes 3 because the rounded down of 3.71 is 3. Change becomes change minus int change. Okay? So what that means is change becomes change minus int change. They could have just said change becomes change minus dollars, but they've overcomplicated it a little bit. So the int of change we know is 3. So change becomes change minus 3. So what we're doing here is we're separating out that decimal. Okay, so change becomes, I've put that one on here again just to keep it simple. I'll put it up here. So dollars, there we go, 3. Change becomes 0.71. Okay, output dollars. All right, so we're going to output the word. So we're going to output dollars, the variable, okay, which is 3, and then dollars, the word, because it's in speech marks. Look out for speech marks, because if you see speech marks, it doesn't mean output the variable that's related to that. It means output the word. So I'm going to output here, because this is the line that we're on now. I'm going to output dollars, oh, sorry, $3, okay, because it told me to put the variable first, because it doesn't have speech marks, and then the word, okay. Right, I hope that's clear. So then we come back over here, we follow this line here. Is the change greater than or equal to minus 5? Let's have a look at our change column. Yes, it is. It's 0.71. So then what happens is change becomes change minus 0.5. As I said, you might be looking at this and just getting totally lost, but that's because you're trying to work it out in your head. You're trying to work out what's happening. You don't need to know what's happening. If you'd never read this, but you just understood the int, if you didn't read this here, yeah, you'd still be doing the same thing. Just follow it step by step. Change is change minus 0.5. So 0.71 minus 0.5 is 0.21. So 0.21. Output 1 50-cent coin. This is all in speech marks, so we output that sentence. Okay, so I'm going to output 150. It's really difficult to write. What happened there? It's really difficult to write on this graphics tablet, so I apologize for that mess. And also I pressed too hard, so it gave me a thicker line. Right. What does it say? 1 50-cent coin. There we go. Okay. Wow, that really is a mess. Oh well, let's just ignore that. Next, we're here. We go down here. 10 cents, yeah, becomes int. Now this is making it even more complicated. So 10 cents becomes the int, which is the rounded down version of change times 10 plus 0.5. Okay, so change times 10 is here. We just move that decimal place. It's 2.1. Okay, plus 0.5 is 2.6. Yeah. However, we're rounding that down with the int, so it's 2. So 10 cents is going to become 2. Right. Don't write it there just because that's blank, because it doesn't relate to the rest of this information here. Every time you've finished on one line, yeah, you go down to the next one. Okay? As I said, it doesn't really matter because they're marked vertically, but it wouldn't really make any sense if I put that up here, because this 2 isn't related to this calculation here. Right. So, int, okay, output 10 cents, 10 cent coins. So 10 cents the variable, then 10 cent coins the sentence. So 10 cents the variable is 2, because it's right there in the 10 cents column, and 10 cent coins. 10 cent coins. Okay. So then we've got is change times 10 minus 10 cents greater than 0? So what's change times 10? Change times 10 is 2.1. Okay. Minus 10 cents. Yeah. Which is 2. Greater than 0. Yes, it's because that would be 0.1, wouldn't it? 2.1 minus 2 is 0.1. Okay. So it is greater than 0. So I'm going to output 1 5-cent coin. So 1 5-cent coin. There we go. Okay. All these are hanging out on the edge there. It doesn't matter. Right, look at the difference here, because I've written a 2 there, with the number, but I've written a 1 here with the word, and the reason was that that was a variable, okay? However, this one, it just put it in the sentence. Then we go down and we end, all right? So all I did there was some very basic mathematics, and I followed the structure, and I got 5 marks for that, okay? So it's a good idea to practice these, but remember, the one piece of advice I would give you when you get this question in the exam is not to overthink it. Don't look at the whole thing and try and figure out what it's doing, because you will just overcomplicate things. You'll end up getting stressed about what you've got to do with the maths. Just go step by step, okay? Follow it very carefully, step by step. Do not try and figure out what it's doing and then fill that in using that information, because there's just far more chance of getting something wrong.